Here we have an example of an indefinite integral because there are no limits on this integral here. The first thing you want to do is rewrite it so that all the powers look like this. So for this one, we've got the integral of 3. Now this is the 4th root of x and it's a denominator. So we're going to get x to the minus a quarter. And then we've got minus 9x to the 5 over 2 with respect to x. So now when we integrate this, we don't need this symbol anymore. We write 3x, then we add 1 to the power. So we're going to add 4 quarters to this one to give us 3 quarters. Take away, oh, we're going to divide by that power. So we're going to divide by 3 quarters. And we're going to take away 9 lots of x, add 1 to the power, that's 2 halves. So we're going to get 7 over 2, and then we're going to divide by the power. You must also remember that for an indefinite integral, when there are no limits on the integral here, we write plus c to represent a constant. Here's another one. The first thing we're going to do is rewrite this term so it looks more like this one. So this is the integral of 2x to the minus 5, because it's on the denominator, minus 6x to the 3 quarters. And we're going to integrate it with respect to x. On this line, we do not write this symbol. We're now actually going to integrate it. So we've got 2x, add 1 to minus 5 to get minus 4, then divide by that power. Minus 6x, add 1 to this, that's adding 4 quarters, so that gives us 7 quarters, and then we divide by 7 quarters, and of course we write plus c because it is an indefinite integral. Let's do one more, but this time I'm going to have limits 2 and 1. So we've got 3x squared minus x plus 4 with respect to x. Now we don't need to rewrite any of the terms this time because they're already written nicely for us, but we do have to deal with these limits here. So we're going to write equals straight into the integration, use nice square brackets for this, 3x, add 1 to the power, then divide by that power, and notice that these 3's cancel, minus x. Now there's a 1 here, so we're going to add 1 to the power, then divide, plus 4x, close the square bracket and write the limits on the end like that. Now to evaluate this, we need to substitute in the value of 2 for x and the value for 1 for x, and then work out the difference between the two. So here we have an answer of 9.5 square units, and this actually represents the area between the curve and the x-axis. We can also check this answer on a calculator. So there is an integral function just here. You press that and then you write in the integral, the original one. So 3x squared minus x plus 4. Right in the limits, so we had 1 and 2, and it gives you the answer 19 over 2, which is 9.5. This is a great top tip for an exam. You can always check your answer for a definite integral. Here are 5 questions for you to try, so pause the video, and then when you're ready for the solutions, press play. Here are the 5 solutions to each integral.